A box with GE light bulbs claims that the average life of a GE light bulb is 1,000 hours. Suppose you bought a box of 100 bulbs and found that on average they lasted only 900 hours. The sample standard deviation was 200 hours. Test the hypothesis that the population average life of a GE light bulb is 1,000 hours, as the box claims, against the alternative that the average life is lower. So we're going to set up the null hypothesis. This is a hypothesis about population mean mu being equal to 1,000 against the alternative, our hunch, that it is less than 1,000. We need to compute the test statistic. The test statistic for a test about means is that the sample mean subtracted from the hypothesized mean divided by the standard error of the sample mean. Now let's calculate the standard error. We know that the sample mean is 900. We know that sample standard deviation was 200. Number of observations was 100. So from these two, we know that the standard error of the sample mean is 200 divided by the square root of 100, which is 20. So plugging this into our test statistic, we have 900 minus the hypothesized value of 1,000 divided by the standard error of the sample mean gives us a test statistic of -5. Let's determine the rejection region. The test statistic, T, bounces around 0. The rejection region is on the left side with the critical value of -1.64 because we're using a 5% level of significance. So if the test statistic falls anywhere to the left of -1.64, we reject the null hypothesis. Of course, in this case, -5 falls well into the rejection region, and we reject H0 big time. Let's calculate the p-value associated with this test. P-value would be the probability that the t-statistic falls into the region beyond -5. So what is the probability that we would get a test statistic as low as -5? And that is, of course, off the charts, and so the probability is 0.